Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And a very good morning. My name is AHMAD RASHIDI bin Ismail. My matrix number B081910319. In this video, today I would like to share what I've done and what I've learned, the latest task under BEE 2373 in the subject of electrical technology, where I've learned and I practice lab 3 about power and power factor measurement in single phase circuit. First of all, I would like to appreciate my lecturer, Puan Dr. Ida Shafiza binti Mat Isa, for his give me an opportunity to learn this subject, and together with my partner, Mr. Zamri bin Zakaria, and also Mr. Muhammad Fadil Baharudin. Okay, so let's start with the first data, where I have to measure the circuit which contains only resistor, the value of 910 ohm. Okay, for this data, the voltage supply is 200 volt, which is AC, and the frequency is 660 hertz, and the resistor is 910 ohm, where I get 219.778 milliampere, and the power I've obtained 43.956 watts, and the power factor is 1.00. Okay, let's see the for the first circuit. Okay, I stop first. Okay, for the first circuit, okay, what we can see, I use the AC supply, which is a 200 volt. The frequency stated here is 60 hertz, and I use three types of meter. First is ammeter, second is voltmeter, and lastly is wattmeter. And make sure, what I can see, make sure the ammeter must connected series with the load, and the voltmeter must connected parallel in the with the load. And the wattmeter, if you can see, there is a multiple port. We have two positive and two negative, which contains a voltage and the current. So the voltage must connected in parallel, and the current must connected series with the load. Okay, let's see. So it shows here the voltage approximately 199.998, which is closely to 200 volt. Okay, and then the current is 219.778 milliampere, and the watt is 43.956 watt, and the power factor is 1.000. Okay, so as we know that resistor itself, purely resistive circuit, there is no leading and lagging current, so that's why the power factor is still 1.00. Let's see for table 1.2, where it contains two components, which is R1 and L1. Okay, where R1 I use still same value, 910 ohms, but L1 I use 2 Henry. Okay, where practically I get 343.1818 milliampere, and for power I get 43.956 watts, and the power factor was decreased. Previously we got 1.00, but this time when I insert inductor, so I'll get 0.63923. Okay, let's see the multisim. Okay, so this is the multi-sim. This is the multi-sim. Before that, this multi-sim I use uh, 14.14.2 version. So maybe my partner used the different version. So I explain here. I use the 14.2. Maybe the figure is slight different. Okay, so what we can see here. Okay, let's start the simulation. Okay, so before this, without inductor, the current is 219.778 milliampere. But if I add the inductor, the current increase to 343.818 milliampere. The current is slight the voltage a bit increase closely to the supply voltage, which is 199.999 volts. And the power before this, we get 43.596. For this circuit, still the same, but the power factor become decrease from 1.000 to 0.63923. Okay, so we will discuss later why this happened. 3. Okay, the resistor still the same, 910 ohm, and the capacitor I use the value of 1 microfarad. Okay, what I get here, the current decrease to 232.433. The power still same, 43.956 watts, and we can see that the value of the power factor almost, okay, almost closely to 1, which is I get 0.94556. Okay, let's see the simulation here. Okay, so this is the circuit for R and C, where R for value of R1 is 910 ohm, and for capacitor I use 1 microfarad. Okay, let's see the result. Okay, so the value of the voltage, okay, a bit closely to 200 volt, which is I get 199.998, and the current I get 232.433 milliampere, and the power still same, like the previous two circuit, where I get 43.956 watts, and the power factor we can see here. This circuit shows that the power factor is 0.94556. 0.94556. Here I stated here the difference between the active power, reactive power, and also the apparent power. And also this is quite interesting. I state here the formula for active power, which symbolized by P, where the value where it comes from V times I cos theta, and reactive power is symbolized by Q, V times I sin theta, and the apparent power, there is two formula, which is symbolized by S is equal to V times I, and also S square is equal to P square plus Q square. Okay, so the unit of the power is watts, and the units of the reactive power is VARS, VARS, and for apparent power is volt ampere. Okay, so that's all I want to share. So I would like to wish thank you to Puan Dr. Ida Shafiza binti Mat Isa for his guidance. Actually, personally, I like to love this subject practically face to face, but in for MCO, PKP is challenge me to learn online. So um, so I'll try my best to learn and to understand. So that's all for me for today. Thanks for watching my video, and hope to see you for next season. That's all for today. That's my presentation, and have a good day. Assalamualaikum warahmatullahi taala wabarakatuh.